What do furniture, sugar, and paper have in common? They are all forest products. Wood has been a veritable catalyst of human evolution. Inflammable, it kept our forefathers warm. Solid and easy to work, it could be used to build lodgings, thus facilitated the settling process. Because it floats, it was used to make ships, which made the great explorations possible. And today still, cabinet makers continue to integrate it to modern life. New materials come into our lives by the scores. Plastics, ceramics, alloys, and synthetic resins are now being used more often than the traditional materials, such as stone, horn, or leather. Wood, however, still maintains an enviable position on this honor roll. Its continued popularity is accounted for by its inimitable natural beauty, as well as its amazing physical properties. To work wood and make furniture or art objects from it, cabinet makers have had to learn about these properties and to master them. Wood is a network of cells whose role is to support the tree and carry its sap. It is produced by the cambium, a living tissue located just under the bark. Each wood cell has a central cavity surrounded by a cellular wall. At the beginning of a cell's life, a living material, cytoplasm, occupied its central cavity. However, over time, the cells die. Their central cavity empties, and their external envelope thickens. These dead cells, which gradually enlarge the tree's trunk, make up the wood. They are arranged like bricks, aligned in the direction of the trunk of the tree. Wood is not a uniform material. As a rule, the wood produced in the spring is paler and more porous than that formed later in the season. As a result, a series of rings are formed that go from the tree's center to its bark. The presence or absence of these growth rings, their shape and orientation, have a major influence on the aesthetic quality of a piece of wood, and therefore on its use. The structure of wood also varies from one species to another. Dense woods, such as maples, are composed of cells with thicker walls and smaller central cavities than soft woods, such as pines. Dense woods are therefore harder and stronger than soft woods. They're preferred, for instance, to make furniture or floors, which are subject to knocks or friction. The first step in furniture making is to dry the wood. Indeed, green wood contains a heavy concentration of water. As the water evaporates during the drying process, the wood shrinks. Because of the cellular structure of wood, the shrinkage is much more pronounced in width than in length. Even when dry, wood continues to expand or shrink, depending on the humidity in its environment. If it didn't, it would be liable to warp and crack. The cabinet maker can also minimize these movements by applying appropriate techniques. The dry wood is cut or graded according to various methods. Wood turning, for example, is used to make intricate table or chair legs. Another method used in industry, wood bending, will even give wood a curvature. The wood is first placed in a steamer containing steam or water at 100 degrees Celsius. As it heats, the wood becomes pliable. This is due to the chemical composition of wood. Its fibers are made up of long, flexible strands of cellulose. They are bound together by a sort of cement, lignin. Normally hard and brittle, lignin is what gives wood its rigidity. However, when heated, it will soften, just like plastic. When the wood is hot enough, the cabinet maker can give it the desired shape with a level press or by placing it between molds. The fibers on the inside of the curvature then have a tendency to compact lengthwise. After drying and cooling, the lignin hardens anew, and the fibers stabilize in their new position. Once cut or graded, the pieces of wood are sanded. They can then be assembled and fine finished. Varnish brings out the beauty of wood furniture, but above all, it helps to curb the wood's humidity exchanges with the environment. Once a cottage industry, the design and production of furniture are now industrial activities that employ the latest in technology. In the mass production of furniture, for example, computer-assisted design enables designers to see how a piece of furniture will look before it is built. Based on the plans for the new piece, the computer draws up a scale, three-dimensional image. The designer can then make the changes he wants. For instance, he can simulate various textures and colors of wood, apply a marbled lacquer, or even simulate certain motions, such as the to and fro of a rocking chair. This technique eliminates the need to create prototypes, which is a long and costly process. Also, it allows the manufacturer to quickly assess the potential market for his new creation. Today's cabinet maker needs to learn to work with the new technologies, just as he needs to know how to blend types of wood. Wood is not the only forest resource. Rubber, gum, alcohol are others. In some regions in North America, even the sweet sap of the maple is collected to extract a variety of delicious products. In the northeast part of North America, the first source of sugar was not sugarcane or beets, but the maple tree. Since the early days, the spring harvest of sugar maple sap and its transformation into syrup have become a tradition. In recent years, this activity has grown into a veritable industry. The sugar maple grows over a large part of eastern North America, where it forms magnificent forests. However, its sap can only be harvested in a relatively small area, an area where, in early spring, the variations in temperature between day and night are extreme. Maple sap runs for a few weeks, and the greater the variations in temperature, the more plentiful the sap runs. In the spring, the maple syrup producer begins by tapping his trees, that is, punching a hole about 5 centimeters deep into the trunk of each maple. In it, he inserts a spout, a small plastic or metal cylinder. Traditionally, the sap was collected in buckets by hand, which was hard, time-consuming work. We now have made inroads in maple sugaring. Plastic tubing carries the sap from many trees down to the sugar house. A pump creates a partial vacuum in the tubing system. It therefore increases the difference in pressure between the inside and the outside of the tree. This difference in pressure improves the sap run towards the central holding tank. When the climatic conditions are right, when it freezes during the night and thaws during the day, a sugary maple sap begins to run. There is as yet no full explanation of how or why this occurs. According to one theory, some of the maple cells contain tiny gas bubbles. At night, due to the cold, these bubbles contract, causing a drop in pressure. To compensate, the tree absorbs water by its roots. During the daytime, as the temperature rises, the bubbles dilate, raising the internal pressure of the tree. This pressure would force the sugary sap to flow out through the holes. As for the sugar, it comes from reserves of starch stored up in the maple during previous years. With the spring, the living cells of the wood release enzymes that convert the starch into sucrose, a compound identical to table sugar. The sucrose dissolved in the sap is what gives it its sugary flavor. An average sugar maple will produce 40 to 80 liters of sap, 2 to 4% of which is sugar. This sap also contains mineral salts and delicate-tasting organic compounds. To obtain syrup from the sap, the liquid has to be concentrated. This is done with a reverse osmosis system, the heart of which is composed of membranes. A pump forces the maple sap to go through these membranes, which only let the water molecules through. However, the molecules of sugar and all the other compounds are retained in the liquid. The concentration of this liquid quickly increases as the water filters through the membrane. At this stage, up to 75% of the water contained in the sap is extracted. The resulting concentrate can then be made into maple sugar. This is done in an evaporator, that is an open, heated metal container. As it boils, the liquid gradually concentrates. At the same time, a series of chemical reactions occur between the sugars and the other compounds deriving from the sap. These physical and chemical changes cause the liquid to brown and greatly intensify its flavor. When its sugar concentration reaches 66%, it is removed from the evaporator. It takes on average 40 liters of sap to yield 1 liter of syrup. The syrup itself can then be processed a number of ways. For example, when boiled a second time and poured onto snow, it forms a thick and appetizing taffy. Boiling has the effect of saturating the syrup in sugar, and rapid cooling, that of preventing it from crystallizing. The syrup can also be made to crystallize by stirring it before cooling it. Depending on the temperature and degree of cooking, the shape and size of the crystals vary, producing a cream, a soft sugar, or a hard sugar. Maple sugar products have unique qualities. To make sure commercial products contain these qualities, they are subjected to various tests. Maple syrup is graded according to its color, among other things, which is assessed by photometer. Also, its density is measured to make sure it contains the right percentage of sugar. There are other tests to authenticate the sample. For example, a measure of electric conductivity will reveal whether commercial glucose has been added. Where there is a doubt, the sample may be subjected to more advanced tests, such as liquid chromatography, which will tell whether it has been tampered with. Ultimately, these tests have but one goal: to guarantee the quality of maple sugar products and the pleasure of eating them. One of the main products derived from wood processing is paper. The applications for paper are ever-growing, from paperboard packaging to writing paper and disposable diapers. However, the way it is made has remained essentially the same. With the proliferation of computers, we expected to see it disappear, and yet it is still with us, whether for writing, wrapping, currency, or a friend for our tender nose. The day the computer screen will replace paper is still a long way off. Paper is an assemblage of fibers, closely meshed and bound together. Paper making is basically a simple process. The first step involves the extraction of plant fibers. The fibers are then mixed with water to yield a milky pulp. If necessary, the pulp is then treated, bleached or colored. It is then poured onto a sieve, where the water drains off and the trapped fibers form a tight web, chemically bound together. When the fibers dry out, they become a sheet of paper. Paper making on an industrial scale is more complex. Nowadays, paper is made from wood fibers. These hollow and elongated fibers, roughly a millimeter long, are the cells of the wood. Their chief constituent is cellulose, a chemical compound in long chains. The main difficulty in paper making lies in extracting the wood fibers. A sort of chemical cement, lignin, binds wood fibers together. The first thing to do is to free the cellulose fibers from their lignin matrix. This can be done by mechanical processes. One such process consists of grating the logs on a rotating wheel, which can be likened to a giant vegetable grater. This mechanical action tears the fibers from the wood and partially separates them. Another mechanical process uses a refiner, a machine with two channeled discs that rotate in opposite directions. Inserted between the discs in the form of wood chips, the wood is chipped into smaller and smaller bundles and finally into individual fibers. Chemical processes are also used to extract wood fibers. Wood chips are pressure cooked in a steam-heated digester to which are added such chemicals as sodium hydroxide and sodium sulfate. These reagents dissolve close to 90% of the lignin between the wood fibers and release the fibers during the chemical pulp preparation. The resulting pulp can be used as is or bleached. Other substances can be added to it to increase the paper's opacity, glaze, or resistance to water. The treated pulp reaches the paper-making machine. This machine consists of a wet end and a dry end. At the wet end, the pulp is delivered between two cloths that move horizontally or vertically. Part of the pulp's water is drained off, first by centrifugal force, and then by suction through the double mesh. The reel of pulp then separates from the cloth and proceeds toward the press rollers. It is conveyed on a felt between pairs of rollers that remove any remaining humidity and make it more compact. Finally, it passes round a series of heated drying cylinders and comes out as a continuous reel of paper. The last stage is the calendering, which softens and smooths the surface of the paper by feeding it through a vertical bank of heavy cylinders. There are a great variety of papers, and each one has different properties that can be measured by specific tests. For example, certain tests will measure a paper's strength. Others gauge its degree of whiteness. As a rule, mechanically processed paper, such as newsprint, is not very strong, and while opaque, is not very white. Chemically processed paper, on the other hand, is much stronger, whiter, and brighter than mechanical paper. It is therefore mostly used in printing. Much research goes into improving the quality of paper. Confocal microscopy, a leading-edge technique, enables researchers to study the structure of a paper with unequaled accuracy. In a few seconds, the confocal microscope draws up a three-dimensional chart of the surface of the sample. The fibers can be visualized on the chart. The paper's behavior during the printing process, for example, can also be studied. Attempts are also made to develop new bleaching processes, which, unlike traditional chlorine bleaching methods, would be less harmful to the environment. In the future, ozone may replace chlorine in the bleaching process. Another promising process currently being developed in the laboratory consists of subjecting the pulp to the action of white rot, a wood fungus. White rot releases enzymes that partially whiten pulp. The process could then be completed with such soft bleaching agents as oxygen or hydrogen peroxide. However, we too can contribute to this environmental effort by simply recycling our old papers. At present, paper makes up the bulk of household garbage. By curbing such wastes, we can help protect our forests and, as a result, keep ourselves alive. The forest has heated, housed, fed, and above all, civilized us. Without the forest, we would have been condemned to a life of hunger and cold in a desert of stones. If we continue to deplete it as we are now doing, that's what may well await us.